Paul introduced us to Pico W timers in Lesson 80. Pico W timers provide a non-blocking way to create timed events in our programs. Our Lesson 80 assignment was to use only timers to blink the red LED asymmetrically, that is, on for 100 milliseconds and off for 900 milliseconds, while the green LED blinks 1 second on, 1 second off, and the blue LED blinks 10 seconds on, 10 seconds off. Our Lesson 81 assignment was to use only timers to drive 4 LEDs to give the appearance of a 4-bit binary counter. Let's start by having a look at how symmetric timing control works. Paul demonstrated how we can use a periodic timer to create a symmetric non-blocking control signal. The timing diagram below shows how this works. Red timer starts when the program starts. Red timer calls the red LED toggle callback function every time the period expires, in other words, every 1000 milliseconds. Each time the red LED toggle function is called, the status of the red LED changes from off to on and back again. Unfortunately, the timer function only has one period parameter and therefore is unable to provide asymmetric control on its own. Asymmetric control can be achieved by adding a red LED off function to the program and a one-shot timer to the red LED toggle function. Not only will the red LED toggle function turn red LED on every 1000 milliseconds as described on the previous screen, but it will also start or restart the one-shot timer each time. After 100 milliseconds, when the one-shot timer times out, it will call the red LED off function and turn red LED off. Since this approach only uses the red LED toggle method to turn red LED on, I renamed the callback function from red LED toggle to red LED on and replaced the red LED toggle statement with red LED on. The program works equally well this way and should also be easier for someone else to pick up and understand. Let's have a look at the Lesson 80 code. We start by importing pin because we're connecting the LEDs, and timer because we're setting up timers. Next, we declare the GPIO pins for the red, green, and blue LEDs and create those objects. Here we declare the red LED on callback function. Notice that this function now includes a one-shot timer, which will call red LED off whenever it times out. We also declare red LED off, green LED toggle, blue LED toggle, and our timers. Finally, we have the expected try except clause. Nothing happens in the while true loop, and the except clause deinitializes the periodic timers and exits gracefully. Let's see how it works. The red LED is on for 100 milliseconds and off for 900 milliseconds. The green LED is on for 1000 milliseconds and off for 1000 milliseconds. And the blue LED is on for 10,000 milliseconds and off for 10,000 milliseconds. That's it for Lesson 80. Let's have a look at Lesson 81. If you chart the on and off times of each bit in a 4-bit binary counter, you will see that the 1 bit has a particular period. Let's call it P. The period of the 2-bit is twice as long as the 1 bit, so 2p. The period of the 4-bit is twice as long again, 4p. And the period of the 8-bit is twice as long again, so 8p. So we should be able to simulate a 4-bit binary counter by creating a periodic timer for each bit and setting the period of each timer in the ratio of 1 to 2 to 4 to 8. Let's have a look at the code. We start by importing pin because we're connecting the LEDs and timer because we're setting up the timers. Next, we declare the GPIO pins for the red, yellow, green, and blue LEDs and create those objects. Here we declare the toggle function for each of our LEDs. We also declare the timers. Notice that the periods of the timers are in the ratios of 1 to 2 to 4 to 8 as explained in the previous screen. Finally, we have the expected try except clause. Nothing happens in the while true loop, and the except clause deinitializes the periodic timers and exits gracefully. Let's see how it works. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.